Hello everyone. In today's lecture, we will see some more questions based on maxima and minima. In the last lecture, we had done practice questions till question number 12. So in this lecture, we will start from question number 13 and we'll do till question number 18. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So let's start with question number 13, which says, if a differential function fx has a relative minimum at x equal to 0, then the function phi x is equal to fx plus ax plus b has a relative minimum at x equal to 0 for which a and b, right? So the hint of this question is we have a differential function fx that has relative minimum at x equal to 0. Then by the use of fx, we made another function which is known as phi x, which can be written as phi x is equal to fx plus ax plus b, right? And we have to find whether phi x has a relative minimum at x equal to 0 for which a and b. So if since f dash x has a relative minimum, therefore f dash x equal to 0 at x equal to 0 and f double dash 0 will be greater than 0. Now for this function to we have to find fx to be minimum. Then first we will find phi dash x. So phi dash x, we will calculate phi dash x and put it as 0. Clear? And we will calculate phi double dash x, and which should be greater than 0 for relative minimum, right? In this way we can approach this question. Okay, so you have 10 seconds to solve this question. After 10 seconds we will discuss the solution. Okay, let's move to the solution part. T. We have phi x is given as fx plus ax plus b. Therefore, phi dash x will be f dash x plus a. Right. So since phi dash 0 is equal to 0, clear? Phi dash 0 is equal to 0. Therefore, f dash 0 plus a is equal to 0. Clear? F dash 0 plus a is equal to 0. This implies a should be 0 since phi dash 0 is f dash 0 is 0. F dash 0 is 0. Right. Also, phi double dash 0 should be greater than 0 because we have to find minimum condition. Since f double dash 0 is greater than 0, right? Therefore, phi x has relative minimum at x equal to 0 for all b if a equal to 0, right? If a equal to 0, then phi x has a relative minimum at x equal to 0 for all b, right? So I think option B is right choice. B. Clear? B is the right choice. Okay, let's move to the next question, which says the denominator of a fraction is greater than 16. 16 of the square of numerator, then the least value of fraction. So the hint of this question is, suppose the fraction is x upon y, then it is asking that denominator is greater than 16 of the square of the numerator, right? So suppose numerator will be x. So numerator is x, then denominator will be x square plus 16, right? Square plus 16 like this. And we have to find the least value of the fraction. Clear? So we have the fx. So to find the least value, we will first find f dash x, which we will put equal to 0 to find the critical point. And at each critical point, we will calculate f double dash x. And if we have to find the least value, then f double dash x at the critical point should be greater than 0. Clear? So in this way, you can approach this question. Okay. So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Let the number be x, then fx is equal to x upon x squared plus 16, as given from the question. The denominator of a fraction is greater than 16th, 16 of the square of numerator, right? Now, on differentiating with respect to x, we get f dash x equal to x square plus 16 into 1 minus x into 2x upon x square plus 16 whole square, right? Which is equal to x square plus 16 minus 2x square upon x square plus 16 whole square, which is equal to 16 minus x square upon x square plus 16 whole square. Suppose this is equation 1. Now, since we have to find the least value of function, that then f dash x should be equal to 0 for maxima or minima. Right? Therefore, if f dash x equal to 0, therefore 16 minus x square is equal to 0, right? So x is equal to 4 and minus 4. Again, on differentiating with respect to x, we get f double dash x, which is equal to x square plus 16 whole square into minus 2x minus 16 minus x square into 2 into x square plus 16 into 2x upon x square plus 16 to the power 4, which we have done by using quotient rule, right? This is f double dash x. Fine. Now, at x equal to 4, f double dash x is less than 0, right? When you will put x equal to 4, you'll get f double dash x less than 0. Therefore, fx is maximum at x equal to 4, and at x equal to minus 4, f double dash x is greater than 0, right? Therefore, fx is minimum. So least value of fx is equal to minus 4 upon 16 plus 16, which is equal to minus 1 by 8, right? So least value of function will be equal to minus 1 by 8. Clear? I think option B is the right choice, minus 1 by 8. Got it? Let's move to the next question. Question number 15, which says the function fx is given as ax plus b by x, where b and x greater than 0, takes the least value at x equal to. So fx is given. Therefore, for maxima and minima, first we will calculate f dash x, right? Right. So the hint is first find f dash x and put it as 0, right? So you will get the critical point in terms of a and b, right? And for this function to be to attain a least value, you must calculate f double dash x, right? And f double dash x, we have to select the critical point at which f double dash x is greater than 0, right? So the point at which f double dash x will be greater than 0 will be the least function. Will take the least value of the function, right? So in this way, you can approach the question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, fx is given as ax plus b by x. Now, as we discussed, on differentiating with respect to x, we will get f dash x is equal to a minus b by x square, right? For maxima or minima, put f dash x equal to 0. This implies x will be equal to root over b by a. Now, we have to find f double dash x. So again, differentiating with respect to x, we get f double dash x is equal to 2b upon x cube, right? So at x equal to root b by a, f double dash x is equal to positive. Clear? At x equal to root b by a, f double dash x equal to positive. Therefore, fx is minimum at x equal to. Therefore, fx is minimum at x equal to root over b by a, right? Therefore, fx has the least value at x equal to root b by a. Got it? So at x equal to root b by a, the function attain least value. Option D is the right choice. Clear? D is the right. Okay, let's move to the next question. Question number 16, which says, let f be a function defined by fx is equal to tan x upon x when x not equal to 0 and 1 when x equal to 0. So we have two statement which says x equal to 0 is the point of minima of f. Statement 2 says f dash equal to 0. F dash 0 is equal to 0. So the hint of this question is the function is given as a piecewise function. So to discuss about the point of minima, we must find f dash x at x equal to 0. So f dash x, we will find f dash x by using quotient rule when x not equal to 0 and equal to 0 when x equal to 0. Right. So we will put f dash x equal to 0 to find the critical point, and therefore after that at a particular critical point we will find f double dash x. Clear? And check whether f double dash x is greater than 0 or not at that particular critical point, right? So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to a solution part C. Fx is given as 10x upon x when x not equal to 0 and 1 when x equal to 0, as 10x upon x greater than 1 for all x belongs to for all x not equal to 0. Therefore, f0 plus h greater than f0 and f0 minus h greater than f0. Now at x equal to 0, fx attain minima. Now f dash 0 is basically f dash 0 will be limit h tending to 0 fh minus f0 upon h, which is equal to limit h tending to 0 tan h upon h minus 1 upon h, which is equal to limit h tending to 0 tan h minus h upon h square using L'Hospital's rule. Clear? Now which is equal to limit h tending to 0 sec square h minus 1 upon 2h. We are applying L'Hospital rule. Since tan square theta is equal to sec square theta minus 1. Now it can be written as tan square h. Since tan square h is theta is sec square theta minus 1, right? Therefore, it is equal to limit h tending to 0 tan square h upon 2h square. Clear? We have multiplied and divided by h. Now, limit h tending to 0 tan square h upon h square will be 1. So it is equal to 1 by 2 into 0. Since limit h tending to 0, h is equal to 0, right? So it is equal to 0. Therefore, statement 2 is true. Hence, both statements are true. So, and statement 2 is not correct explanation of statement 1, right? So I think option B is the right choice. Statement 1 is true, statement 2 is true, and statement 2 is not a correct explanation for statement 1, right? Okay. Okay, let's move to the next question, which says the absolute maximum and minimum value of function a function f given by, we are given a function f x is equal to cos square x plus sin x when x belongs to 0 to pi. See, 0 to pi is end points, right? And we have to find absolute maximum and minimum value. So the hint of this question is first we will find f dash x, right? F dash x equal, and we will put f dash x equal to 0 to find the critical point, right? After finding critical point, we will check for f double dash x, right? So the point at which f double dash x will be less than 0 will be local maxima, and the point at which f double dash x will be greater than 0 will be local minima. Now we have calculated local minima and local maxima. For absolute maxima and minima, we must calculate the values of function at endpoints, right? So we will find f0 and f pi and check whether it is coming greater or less than the previously calculated value. In this way, we will find the absolute maximum and absolute minimum values of a function, right? So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Given fx is equal to cos square x plus sin x when x belongs to 0 to pi. Now f dash x equal to 2 cos x into minus sin x plus cos x, which can be written as minus 2 sin x into cos x plus cos x. Now for maximum or minimum, put f dash x equal to 0. which imply minus 2 sin x cos x plus cos x equal to 0. Now, if we take cos x common, we'll find cos x into minus 2 sin x plus 1 is equal to 0. Therefore, cos x equal to 0 or sin x equal to 1 by 2. Clear? So the critical points are basically pi by 6 and pi by 2. Clear? Now for absolute maximum and absolute minimum, we have to evaluate f0, f pi by 6, f pi by 2 and f pi. Clear? Now at x equal to 0, f0 will be cos squared 0 plus sin 0, which is equal to 1. Now at x equal to pi by 6, f pi by 6 will be equal to cos square pi by 6 plus sin pi by 6, which is root 3 by 2 square plus 1 by 2 square, which after calculation you will get 5 by 4, which is 1.25. Now at x equal to pi by 2, f pi by 2 is cos square pi by 2 plus sin pi by 2, which is equal to 0 square plus 1, which is 1. Now at x equal to pi, f pi is equal to cos square pi plus sin pi, which is equal to minus 1 square plus 0 is equal to 1. Hence, the absolute maximum value of f is 1.25, occurring at x equal to pi by 6, and absolute minimum value of f is 1, occurring at x equal to 0, pi by 2 and pi. Right? Clear? So you can also note that if closed interval is given to determine global maximum or minimum, check the values of critical points as well as endpoints of a given interval, right? So this is important note you have to keep in mind, right? Okay. So I think option B is the right choice. 1.25 maximum value is 1.25 and absolute minimum value is 1. Okay. So let's discuss next question number 18, which says the maximum value of fx is equal to x upon 4 plus x square on minus 1 to 1 is. So the hint of question is same. First we will fx is given. First we will calculate f dash x, right? We'll put f dash x equal to 0 to find the critical point. Clear? We'll calculate f dash x by using quotient rule. And at each critical point, you will find f double dash x. Clear? F double dash x. So f double dash x. And we will also check at the endpoint at minus 1 and 1, right? So at critical points and at minus 1 and 1, we will check whether the function attaining maximum value at which point, right? So in this way, you can approach this question. Now you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. Since fx is equal to x plus 4 upon 4 plus x upon 4 plus x square. Now on differentiating with respect to x, we get f dash x is equal to 4 plus x square minus x into 1 plus 2x upon 4 plus x square whole square. For maximum, put f dash x equal to 0. Put f dash x equal to 0, therefore 4 minus x square upon 4 plus x square whole square is equal to 0. Therefore x equal to 2 and minus 2. So both the values of x are not in the interval minus 1 to 1. Therefore f minus 1 is minus 1 upon 4 minus 1 plus 1, which is equal to minus 1 by 4. Right, and f1 is equal to 1 upon 4 plus 1 is equal to 1 by 6. Clear? Which is maximum. Right, which will give maximum value. Clear? So I think option C is the right choice. Clear? C is the right choice, 1 by 6. Got it? So the maximum value of function fx is equal to 1 by 6. So in this way, we have discussed a lot of questions based on maximum and minimum concept. Hope you understood the concept and you understood each and every questions. Right, and hope you liked the lecture. Okay. Thank you so much.